Okay, so this is selecting the right Apple Silicon generation for efficient CI. And yeah, we're gonna, I'll introduce myself and then we'll get into the agenda. So my name is Ben Boral. I am a solutions engineer here at Bitrise. We're a CI tool built for mobile developers. I've been doing mobile for a while, and I got into DevOps in 2018. And that's because I've experienced firsthand dysfunctional software development and delivery processes. And so I became really, really interested in how to make that better. And that's really going to be part of the theme today, which is that when you have performant and an efficient CI system, it means that you're going to use it and it's going to be painless. So you'll actually continuously integrate. And so our agenda today is a little bit of background on Apple Silicon, and then we'll look at some real-world benchmarks from the various machine types. We'll talk to my guest, Adam Wareing, who is the tech lead at Australian Broadcasting Corporation, and then I'll share a little bit of tools and ideas for how you can measure performance and run your own benchmarks for your own workloads. So I want to start with a poll question, which is for multi-core workloads, what is the faster Mac computer? So is it the M2 Ultra, which is that like top of the line gigantic machine, but previous generation, or is it the M3 Max, which is the latest generation? So give a couple of minutes there. Okay, so I'm going to pause the poll, and 2/3 of you roughly said M2 Ultra, or yeah, exactly 2/3 of you said M2 Ultra, and 1/3 of you said M1 Max. The benchmarks provided by Geekbench, which is a company that builds some software for benchmarking performance. So the Geekbench benchmark is that the M2 Ultra, the older machine type, is faster than the M3 Max, the newer one. Now it's just faster by a little bit. And kind of interesting, you can see on that chart, the M1 Ultra is faster actually by quite a bit than the M3 Pro. So we're going to talk throughout this webinar about some of the factors that influence these results, and I think you'll start to see why the results are the way they are. There are some assumptions that are built into this discussion. So when we're talking about benchmarking machine performance, we could be doing that for any number of applications. It could be for like some model training. It could be for video rendering. In this case, we're focusing on CI builds. Within that, we're focusing specifically on Xcode build as our build tool. There are some teams that use other build tools like Bazel and Buck. We're ignoring that for now in terms of the benchmarks that I've taken, but I think the general concepts carry through. As far as the execution environment, you can run your CI builds on bare metal on the machine itself, or you can run them in a virtual machine. And in the context today, we're focusing on virtual machines, and I'll talk a little bit more about why. And then the last assumption is Intel is history. If you are building on Intel still, I'm sorry. And I hope that you will be able to move over to Apple Silicon because the performance difference is significant. But the focus of this talk is really within Apple Silicon's been available for 4 years now. So there are a number of different options there. And so the focus of this talk today is distinguishing between those options. So high level, what are the factors that affect the performance of your builds, at least in terms of the machine that they're running on? So number one, of course, is the processor generation. So we started way back in 2020 with the original M1, and then we got the Pro and the Max, and then the M2 series and the M3 series. And with each generation, these CPUs get faster than their predecessor. The next factor is the CPU core count. And what you're going to find as we go through this webinar is that Xcode build makes really efficient use of multiple CPU cores. So it can parallelize that compilation process across all of the cores available to it. And so in many ways, performance is a function of the number available CPU cores. That's not always the case with whatever workload you're running on, but with Xcode build, it is the case. So the next thing is performance versus efficiency cores, and this is an Apple Silicon concept. When you buy, let's say, a 10-core machine, 10-core Apple Silicon machine, not all of those CPU cores are equivalent. The performance cores are larger. They have more transistors, so they're faster, and they use more power. The efficiency cores are smaller. They use less power. And so obviously a performance core is going to rip through some task faster than an efficiency core. And then the next thing is Ultra Fusion. This is Apple's marketing term behind the Ultra machines. It's that fast interconnect between. So the Ultra machines, they took a Max chip and a Max chip, and they connected them together. And the Ultra Fusion is that connection between them. I'm going to discuss the implication of that in a moment. In terms of the different CPU generations, the difference between like the base model and the Pro model, we can see, is double the number of transistors on that CPU. And then going from Pro to Max is, not quite double, but still significant. Going from, one series to the next, M1 to M2, increases by about 25%. And then we're going to see, in the benchmarks that I've run, these results are not going to match what you see here in terms of transistor count exactly, but you're going to see something similar to that. CPU core count, as I said, is extremely important. And so we can see that going from the base model to the Pro and the Max gets you additional cores. And then, it gets you 4 additional performance cores. And then for the Pro and Max, going from M1 to M2, you're getting 2 additional efficiency cores as well. Okay, so let's just talk a little bit about virtualization. Why did I scope this discussion specifically to running benchmarks on VMs? It's because all of the major cloud providers of CI run those builds within virtual machines. As it relates to performance cores and efficiency cores, Apple's virtualization framework decides how to schedule different workloads on the different CPU cores. And all of the virtualization tools that I'm aware of for Apple Silicon are built on top of Apple's virtualization framework. There are some significant benefits to running in VMs for your CI. The first is that every time you start a fresh job, you get a fresh VM. Those VMs are identical at the beginning of every build, and so you get some reproducibility, some deterministic builds because your environment is always identical. In terms of security, if you're running in a multi-tenant cloud CI environment, then you want that VM isolation. You're going to have source code that you're going to fetch and build. And at the end of that build, your VM gets destroyed, and the source code and any other sensitive files that are on the file system get destroyed along with that. So for that reason, and for those reasons, the benefits, they make up for a roughly 10% performance tax that you'll see compared to just running on the bare metal itself. Last bullet point here about NUMA. So NUMA is non-uniform memory access. Going back to the Ultra machines. So you've got a max chip and a max chip, and they're connected up with each other. And that means that you've got some memory on the left and you've got some memory on the right. And that makes it non-uniform memory access. If I am a CPU core running on the chip on the left and I need some memory that's on the right, that's going to take longer to retrieve than if I get it from the same chip. So unfortunately, the virtualization framework support for NUMA is not really there yet in terms of performance. And so it's not really worth it to run CI jobs in VMs on the Ultra machines. So we're going to take the Ultras out of the conversation, and that's because they're not really provided by any of the vendors. What is available, so I took a quick survey of GitHub Actions, Circle CI, and of course Bitrise, and these are the machines that are available. So going back to the original M1 Mac Mini from 2020, the M1 Max, and then the more recent M2 Pro machine. And Apple skipped M3 for Mac Mini. So those are what's commonly available, and you can get a rough idea for who's offering what and in what size. So have to proudly point out that Bitrise is the only CI provider that's providing you some relatively large machines, and we'll see the implication of that in the benchmarks that I'll show you shortly. One other note, if you follow the Apple rumor websites, M4 is due to be announced in about a week, at least according to the rumors. So the M4 Mac Minis are going to be announced in a week. We plan to be the first to offer the M4 as well. But let's dive into benchmarks. So I've selected 3 projects. We're going to look at build performance across each of those 3 and understand the characteristics of the different machines with those builds. that will hopefully help you to make some informed decisions about what your own project should be running on. So the first tool that I'm using is Xcode Benchmark, which is really just a collection of several large CocoaPods that results in about 1 million lines of code. And I've run the Xcode Benchmark tool on all of the VM sizes across different Apple Silicon generations on Bitrise, and these are the results. So I think the first thing to notice is there's a really large range here with, on the right side, the M2 Pro 12-core VM being twice as fast as that original M1 Mac Mini with 4 CPU cores. But if we sort of look a little bit more closely, we can see some other interesting trends. So the first one is that there is very much a correlation between the number of CPU cores and the amount of time it takes to run that build. So you can kind of see that on the right side of the chart, where the 6-core M2 Pro machine is slower than the older generation M1 Max at 10 cores, and then the 12-core M2 Pro is the fastest. I'm going to move kind of quickly here through the other benchmarks because we've got a lot of interesting info. So the next benchmark is Signal. It's an open source encrypted messaging app. It's 645,000 lines of code. And, instead of something a little bit contrived with a bunch of just CocoaPod libraries thrown together, this is a real world example. And here, what we see is something similar to the previous one, which is that on that original M1 with a 4-core CPU, there's a kind of a big line that you can draw between that and everything else. Kind of a step change from that to the rest. The rest of the machines are a little more tightly clustered. But what we can again see is that 10-core M1 Max is not a whole lot slower than the M2 Pro with 12 cores. And so that really reinforces that for a non-trivial project that you're compiling, CPU core count is really the most significant factor. And if let's say your company has invested heavily into M1 Max and you have a bunch of those running, probably doesn't make a lot of sense to go to the next step up. So let's see an example of a much smaller app. So this is Backyard Birds. This is an official Apple sample app that I downloaded off of Apple's website and loaded it into GitHub. It's about 8,000 lines of code, so it's like 2 orders of magnitude smaller than what I just showed you. And here we can see, again, step change from that 4-core original M1 VM, and then tighter clustering amongst the rest. But I think what's interesting here is that the 6-core M2 Pro has jumped out in front of the 10-core M1 Max. And so what we can say is that on small projects, that generation of Apple Silicon is going to be a lot more influential than CPU core count. So summarizing, right, for big projects, CPU core count is the most important thing. Run it on the biggest possible machine you can find, even if it's not the newest. For little projects, find the newest machine, and it doesn't have to be big. And then overall theme is, if you are still running on the original M1 and you're running on a smaller VM, then you will get a step change no matter what you change to. So you'll get a step change improvement no matter what Apple Silicon generation or VM size you change to. So those are some benchmarks that show you the performance improvement from machine to machine. And with that, I want to talk about what does it actually mean to a team. And so I'm going to invite Adam. Adam is the tech lead at Australian Broadcasting Company for mobile. And so I'm going to stop the share. Okay, cool. I think we're good. So Adam, thank you for joining us. And yeah, first of all, could you just tell us what is ABC? I cannot hear Adam. Let's see, but let me just ask the chat if you all can hear Adam.
Can you hear me now?
Yeah, now I can hear you. Great.
Awesome. Yeah, the ABC is a government-funded company, so we're independent of it. They don't have jurisdiction over us, and our job is to provide news, audio, and video content to the Australian public.
Cool. I am somebody who actually, even though I live in the US, I've over the years sometimes I listen to ABC on the web stream, so I'm a user. Adam, I know your team is currently running builds on the M2 Pro, and it's been, I think there's been quite an improvement to the developer experience over the past year. And so I was hoping that you could tell us a little bit about the story going from, let's say starting 1 year ago and where you are today. What were your goals? What were you hoping to accomplish over the past year? And what have you accomplished? What does that meant for your team?
Yeah, sure. Our team was a lot smaller a year ago. We had some of the apps were outsourced to external companies, so we didn't have to manage them. We've recently hired quite rapidly. We've built up the mobile team, and with that, that means our output's actually gone up a lot. So our current way of managing CI was just not keeping up. We had an operations team, and they would have in Sydney a bunch of Mac Minis. We used Bamboo. It would just run on those, and yeah, it really wasn't keeping up. We found there was a lot of differences between them. Some of them were Intel based, some of them were Silicon based. They'd have varying versions of Xcode. There was no certainty with what we were going to kind of be getting, and sometimes we just get builds that would succeed depending on the agent, or some that would fail. It was a real problem to navigate, and then we'd kind of run into all the issues of running out of memory, things like that. The biggest though would have been the agent wait time. So because they would only run, I believe, one build per machine, per agent at a time, it was a really low cap. We would be waiting up to an hour and a half, 2 hours sometimes before we'd get a single build through, which is just not good enough. We have a focus on trying to continuously integrate. So we set the expectation that we expect developers to be making approximately one pull request per day to just reduce that iteration time. And that ties into the larger technical direction that we're setting, where we want to release fortnightly, whereas previously that was about every 3 months we were going out. So we want to minimize time from idea to in the public's hands, essentially. And that current solution just wasn't working for us. If someone put up a PR, you've got to wait 2 hours for it, half an hour for a build, you get feedback on it, it's almost like a whole day. And then that night it would trigger and deploy. Since then, we've looked at various options. We identified as Bitrise being the best for iOS and Android development as a whole. So we went with this different option compared to the rest of the organization. We obviously have no wait time now with Bitrise, which is fantastic. So that hour-and-a-half period's gone down to 0, and build time, I think, is about 5 minutes. So from 30 minutes down to 5 minutes. So, we're talking 2 to 2.5 hours previously from triggering, waiting to success to about 5 minutes. So it's just allowed us to move really quick. And when something comes up, when we need something out there, we can be about 15 minutes from pull request made to in a QA's hands, which is just fantastic.
That is fantastic. What did you say? So you said that you were releasing every 3 months, and how frequently are your releases going out today?
We go out fortnightly now.
Okay, that's a great improvement. So I said at the beginning of this talk, I'm super into DevOps, so that means I'm into the Dora metrics. And one of the things that we know from the Dora research is that by increasing the frequency of your releases, that has a direct influence on user satisfaction, on the sort of business level performance metrics. So really cool.
Yeah.
I would love to talk more, but we're getting short on time. Was there any parting words or anything that you wanted to share with the audience, Adam?
Yeah, I guess we've probably got some developers in the room here. We're currently hiring. If you're a great iOS or Android developer and you want to work for a company that does great good, uses the latest technology, has a great developer experience, we're hiring. So please reach out with your CV. You can jump on the ABC's website or seek to find us.
Awesome. Thanks, Adam. And I got that link actually right here. So abc.net.au/careers. If you want 5-minute builds, then that's the place to go. Okay, thanks a lot, Adam. I'm just going to close it out with one last slide. So Telegraf is a cool tool from the InfluxDB people. It's basically, if you're familiar with the Linux command top, it's top on steroids. It gives you all sorts of resource utilization metrics. I've provided 2 steps that I wrote, Bitrise Telegraf sampler and visualizer, just give you an idea of what these steps do. I'll share my screen real quick. The sampler will take every 10 seconds, look at CPU utilization and print that to your Bitrise build. And the visualizer will, at the end of your build, show you the utilization over time. I wanted to show you this because what you can see here is that every CPU core is being used in a really clustered way. If I switch over to a process that runs single core here, that's what that would look like, really uncorrelated CPU utilization for each core. And so that really proves the point that CPU core count is so important for Xcode build performance. And it's really, for any non-trivial project, really the thing that I would focus on if you're trying to optimize for that. So last message here is basically, play around with that tool if you're interested. And also, if you need access to additional machine types, you want to benchmark across all of the machine types that I showed you today, you can just shoot me an email, benboral@bitrise.io, and I can get you trial access to those machines. And that's it. Thank you so much, everybody, for joining. And you've got my email there if you need trial access or just if you've got any questions. Thanks so much to Adam for providing that like real world viewpoint. And everybody have an excellent evening or an excellent day wherever you are.